Good evening, everyone. Am I audible? Okay, thank you. My screen is visible. So, I will continue with week 4 concepts, okay? So, we have callbacks and iterators remaining. So, I'll start with callback. Okay, so consider this particular example where we have a class called my class and another class called timer. And what we'll do is we'll create an object of timer in our my class and we'll call a method called start from this my class. Okay, that is a normal creation of object and calling a method. And once we call that particular start method, so the start method will start executing, and once it is done, it will call the timer done method of my class in return. So that is why it is called as callback. So my class will call the start method of timer, and after timer get the start method get executed, then it will call timer and method of my class. And one more thing to notice here is this usually when we call a function or a method, that it will suspend and the other method will be executing, and at the same time whatever and the main method will stop its execution for some time till the method completes its execution and come back. The control should come back to the main. But in the case of callback, what we are trying to achieve is when we call the start method will continue its execution at the same time. Whatever that is in the my class, the remaining statements, those will also execute in parallel with this particular call. So you don't have to think much about this. Just remember that here we are not suspending the call, rather both are going to be executed parallelly. So yeah, now see this timer class, and we'll see the code for this particular my class here. So this pseudo code here you can see. Here we have a f method in my class, and this f method is going to create an object of timer, and t is our object, and it is taking this particular structure, and here we working t dot start method of timer class, and here we have timer done method, and in class time you can see here honor. So honor is what it is doing. It is going to initialize the value for honor. So who is the owner that called this particular start method? For that we are keeping track of the information. Who called this particular start method? Because we want to call back the timer done method of the class that called start method of timer. So here honor equal to O, which is of type my class. Just focus on this. And then this is our start method, and start method once its statements are executed, last it is going to call the timer done method using this variable honor dot timer done. So we will come here, and the rest of the things will be executed for the timer done method. So this is basically an indication that this particular start method has completed its execution in the timer class. Want to be something very specific to only one class. What we want is the timer to be a generic that can take any honor. not just my class. Any class can call the start method of the timer class, and it has to call the timer done method of any class that call the start method. So we want to make the timer class as generic. Or here this owner shouldn't be just my class. We are expecting we are expecting something that can call the timer done method of many other classes, multiple classes. So how can we achieve this? So there comes making the owner as object type. So we know that if we have object type, this object type can take any type, right? So as it is on the top of hierarchy, class hierarchy, object can take any other classes as the objects here. But one problem here is, okay, constructor thing we can solve. We can have our owner as object type. We don't have to specify my class here. We made it generic now. But here, the timer done method is not present in our object class. So we cannot call it directly using owner. Rather, we have to typecast back to my class to have access to timer done method. So again, this is not solving that. We cannot have this as a generic timer. So the next solution that we have is, and the proper solution is having an interface, a public interface timer owner, and let's have this method timer done as an abstract method in this interface, and whichever classes that wants to call the start method of the timer has to implement this timer owner interface and also give an implementation for the timer done method. Now in class timer, the changes that we have to make is, one thing is the type of owner can be changed to timer owner. Okay, and here now it is timer owner. And when we call the timer done method, we don't have to do anything, just call it, because this my class is implementing the timer owner method, and this timer done method is coming from timer owner interface. Are you getting it? Anybody has doubt, or is that fine? Why so silent? Kripusudan, Sayan, any doubt?
No, ma'am.
If you're not getting, you can tell me, okay? I'll repeat. Okay, fine, fine. Everyone fine, huh? If it is fine, then I'll go back here. So let's have one same code implemented here. You can see this is our my class, and here this is our method ef that we already saw. So here we are going to create the object of timer t, and here we are calling the start method, and this is our timer done method. And here this is our class timer, and the object owner we have initialized with the o that we call while creating the object timer, so which will be basically my class object. And this is our start method. Here we'll give some logic for start, and finally we will call the timer done method of owner class, which is my class in this case. And yeah, this is a run method. You just leave it now. Now in main method we will create an object of my class and invoke the method f. When we call f will call start method. Once its execution is completed, we will call the timer done method here. So basically we'll get the output as timer started, and then once it is completed we'll go back here and we'll get timer is done. Let's have a one more example. So see here, we have an interface notification. Okay, this is the solution. So that we have a generic notification, just like a generic timer. And this has a method notification, an abstract method. And here we have the class working day, and the class working day is implementing this particular interface notification. And here we are giving the implementation for notification. Today is working day. And we have another class weekend that again implements notification. And here we have notification method implemented, and this is going to print today's weekend. Now here we have a class called timer, and we are creating an object of notification to track which class is calling this notification method, either working day or weekend, for this particular example. And here we have a start method that takes a date object, and then so date is a class that we have. So we are checking the day of the date is 6 or 0. If it is 6 or 0, then it means that it is Saturday and Sunday, which is weekend. So then we are going to create an object of weekend, okay, and that we are assigning to our variable n, which is of type notification, and then calling the notification method of that particular class. Otherwise, if it is not 0 or 6, for all other days, we are going to create an object of working day class and then calling the notification method of working day class. So according to that days, we are going to call notification of either working day or weekend. Now, here we are creating an object of timer and then calling the start method by giving an object of date. So let's try to run this. Okay, so today is Saturday, right? So we'll get today's weekend. So according to that, we are getting this. Are you getting what is callback?
Yes, ma'am.
Okay. So our next topic that we have is iterator. So consider what is iterator. Iterator means, suppose we have a collection, might be you have learned in Python. So suppose we have a collection like an array or some other collections. So that will have more than one elements, right? So we want to loop through each of the elements of that particular collection. So basically now we have this for loop. We have enhanced for loop as well in Java, where it will take for some type something in a collection, maybe list or something, and we can iterate through the elements. And anyway, we have iterator. So why we need iterator is, consider this example for linear list. So we'll go with linear list example. So so linear list is our consider it's a linked list. So we have our data and address in nodes, storing in nodes. Okay, and we are making this particular node as private. We don't want the data inside the node to be available for everyone. So we'll make this node as a private class, and this node has a data part and the address part. Okay, and this is the constructor to create a node. So when you create an object of node, so we'll get a node and we'll add the data, and the next part will contain the address. So basically, we'll keep it as null because the last node will point to null. Now that is how we create a node. Okay, that is private class node here. And in our list, linear list, we have this head node. This is the head of the linked list. So the first node will be head, and head won't be having any data. Head will be kind of a pointer to the complete linear list, complete linked list. So head will point to the first element. If none of the elements are present, then head will be null simply. Now here we have append method. So append means add to the end. You might have seen in a list, when we append an element to a list, it goes at the end of the list. So in linked list, suppose we are calling the append method using a node, then so when we call, it will create a new node with the data that we pass, and it will check whether head is null. Head is null means now it is an empty linked list, and if it is null, then whatever node that we created, new node with the data, to that new node, head will point to that new node. Okay, now that is in the case of when head is null, the first element we will add, and head will point to new node. Now else, if we already have some elements in our linked list, in that case what we will do is we will have a temporary node, and this temporary node will store the address that head contains. Okay, and then it will take a while loop, and will check whether the next address pointed by temp is null or not. So till we encounter a null, we will loop through this particular linked list, and we want to add at the end, right? So when we get when we get at the last node, then there we will add our uh, new node. So this while loop will help us to reach the last node. We'll reach till the last node, and then once we reach the last node, once temp dot next is pointing to null, which means we reach the last node, then we'll add the new node there. So we completely added the new node at the end of the linked list. That's how we add at the end of the list. Getting it? Is it too much, or are you able to follow it?
It's fine.
Okay. So this is our appending. Now, now comes the concept of iterator. Why we need iterator? So we said that this node is private class. So we don't know what is inside the node and how we can directly get it. So what we can do is we'll have an iterator, another private class. So this, let's see the interface iterator. Where is it? Yeah. So iterator, using iterator, we basically iterate through the elements of a particular collection. Here in this case, a linked list. And what is iterator offering is two methods, has next and get next method. And has next method is going to return as a true if an element is present at the next position in that particular collection. And get next is going to return as the element at the next position. So this is going to return as a boolean value if an element is present at next position in the list or any collection, then it is going to return as a true. Otherwise, it is going to return as a false. And get next is going to return as the value or the object through this particular capital object. Okay, so maybe we need to typecast into our type. So these are the two methods offered by interface iterator. So these are abstract methods, and this is our public interface, which means if some class implements this particular interface, then we will get an access to has next and get next method. Right now, what we will do, we will have a private class that here we named it as iter that implements this public interface iterator, and we are going to give the implementation for has next method and get next method in this particular class. Now here we have private node, we took a position, a variable as head. Okay, we started at head. And here we have a as next method, how it is implemented, position not equal to null, which means we are checking whether there exists a next node or not. Okay, it will return true if there is an element present at the next position. Otherwise, we'll get a false. Now, get next method. So it will call. So for get next method, we need has next, use of has next method. It will first check if there is an element at next position. If has next returns as a true, then that means there is an element present at next position. So we will get that data. In this case, as it is a linear list with the data, so we will get the data using the variable position. Okay, because we are checking with the position, right? Here we stored the value of head here. Now, once we get that value into our data, we'll change the position to the next node's address, position dot next. This will move to the next node, and finally return the data. In this way, we will get data of a node at a time. And if we do not have any node, then we'll just return null. Okay. So this is how we implement has next and get next method for this particular linear list, this particular collection. So in this way, for every collection in Java, already this has next and get next method are implemented. So here we are trying to explain only the concept, how it is actually done inside. Okay. And this is a private class header that implements iterator, and here we implemented the methods has next and get next. And now how to get an object of that iterator? Now we have to write a public method outside the private class. Okay, outside the private class, inside the class linear list. So public iterator, we define a method get iterator, and here we are returning an object of this particular iter. Getting it?
Yes, ma'am.
Okay. Now, let's see in the main class what we are doing. Here we are trying to create an object of linear list L new linear list, and What we are going to do, we are appending this value hello for the first node, and next appending world. So we have append method here, right? Using that append method, we are adding the values. Now we are trying to get an iterator. So how to get the iterator? Want to call this particular method get iterator. Okay, using L will get access to get iterator method because get iterator method is present in linear list class. So L dot get iterator, and the return type we can keep it as iterator as it is a public interface. So it is available here. We can access it. So iterator I is equal to L is the object, linear list object dot get iterator. Now here we are calling has next method while I dot has next. If it returns true, then we'll call I dot get next to return the values. Finally, we'll get the values hello and world. Understood? Do you have
System.
any doubt? Okay. So that is about iterator. You just have to remember that it is a public interface and it gives us has next and get next method. Now, sorry. So now, yeah, what we can do is anybody reached? My iterator is not a keyword. No, it's not a keyword. Basically, here we are having a private class, sorry, an interface iterator. So if you go through documentation, so you will get to know more about this when you learn sixth week contents collection. So we have interface iterator, which is already defined a public interface, and that gives us this method has next and next. Here the name is just next. Has next returns true if the iteration has more elements. Next returns the next element in the iteration. Basically, it's an interface. Now, what we can do is let's go for some questions, live coding questions. Theory is over, okay? So, this particular question, write a Java program as instructor. So, here we have to add an abstract class UPI payment has two abstract methods, abstract void payment and abstract void rewards, and class phone pay that extends class UPI payment and that has the following members. One is int amount as private instance variable and then constructor to initialize this instance variable. Then you should override the method payment such that the overridden method displays PhonePe payment success and invokes method rewards. Next thing is you should override the method rewards as follows. Here you have to put some condition. If amount less than 500, then you have to display the message sorry no rewards. Else, if amount greater than equal to 500, then display the message 10 off on next mobile recharge. Maybe. So that's about class phone pay. Then you have to add class Paytm that extends class UPI payment again and has the following members. Private int amount as private instance variable, constructor to initialize instance variable. Then you should override the method payment such that overridden method displays Paytm payment success and invokes method rewards. Again, you have to override the rewards method. If amount less than 500, then you have to display the message sorry no rewards. Else, then 10 off on next DTH recharge. Then next class UPI user and it has the following method public void transfer and get rewards that takes UPI payment object, this one, and invoke the method payment using obj that we pass. Now, in class abstract test, it has the main method and has the following functionality. It will create an object of UPI user, then take two amount for PhonePe and Paytm, and then invoke method transfer and get rewards that we have here by passing. By first passing object of PhonePe with amount A1 as parameter, then by passing object of Paytm with A2 as parameter. Can you try this out? I'll give you some 5 minutes. You have this PDF, right? But everybody is very silent. You'll try it out, right? Or should I solve it directly?
We can try.
Sorry, you will try, you said?
Yeah, yeah, yeah.
Okay, I'll give some 5 minutes. I will get back at 8:40. Everyone, please try it out. Do you have any doubt in the question? Anybody wants help?
Just a question over here.
Yeah,
Uh, Ma'am, the question says if it's five less than 500 and
yeah.
else if it's greater than 500. So, ma'am, logically, if we see, if we are applying the if, I mean, I actually tried that way. I haven't tried the output, I mean, by running. But, ma'am, the
Mm-hmm.
logic says if anything is less than 500, if we are putting it into the bucket, then whatever comes
Mm.
next, we don't need to put else if. So, if we put else, then that's also fine, right?
That's also fine.
Or,
Yeah.
no, no, ma'am, one
Here, yeah.
the equality condition won't be satisfied, right, if we use else, or would it be?
Yeah, because amount less than 500, everything below 500 will go there. Mm,
Okay, so
then,
equals and okay, okay, understood.
yeah, just no need to be specifying that. Done. Okay. Sayan, you can share your screen.
Okay. So, ma'am, this is the exact thing which I was asking you. So, this in the question statement, it was given else if. So, I put the else. So, I don't need to
Mm-hmm.
put the condition. So, ma'am, these two things I had to add. Firstly, this and this, the overriding things. So,
Yeah.
firstly, the payment method. So it said like, okay, the payment is successful, so we just do phone pay payment success,
Mm.
and then we need to call the reward depending
Right.
on my amount, whichever the transfer thing happened, for whichever money got transferred. So we need to call this rewards. So if the amount transferred which is less than 500, then the user would get no rewards and this message would be printed.
Mm.
And if it's greater or equal to, that means else case, the user would get 10% off on the next mobile recharge.
Yeah.
So this is for the phone pay.
Right.
Similarly, for this UPI payment, for the Paytm, again the same thing. I just copy pasted it actually because the thing was same. Just changed the print message.
Okay.
It's for
Yeah.
Paytm, so Paytm payment success. And similarly, I just overridden this rewards. And before that, I called this. So whenever this method is getting hit, so this rewards would get hit as well based on that amount which is being transferred. And based on that, again, so if it is less than 500, there would be no rewards. And if it is greater than, so this time it would be DTH recharge 10% off. So this is exactly what I did.
Yeah. Good. So you understood, right? Method overriding, abstract class, and condition. Condition anyway. Yeah. Fine only.
Hmm. Yeah.
Yeah. And what about that UPI user class? You defined a method, right? Transfer and get rewards.
Which one, ma'am? You're trying to say?
Go down the last
Hmm.
part. Yeah. On line
This one.
49. 49.
This
Yeah.
one.
Right. Yes. Yes.
This one, ma'am, I have slight confusion about this. So that means,
Mm.
I mean, over here at the signature, the method signature. Firstly, this is the method name. That's absolutely fine. But over here, we are actually passing a reference object, isn't it?
Yeah.
And
So
this reference object we are passing, and on that we are calling payment. Is that so? I mean, is that this simple or
it's
something else
like,
is there?
yeah, what thing is, you can see the other two classes, Paytm and PhonePe, both are
Hmm.
implementing UPI payment. So we can say that
Hmm.
UPI payment is kind of parent to both the other classes.
Hmm.
So,
Following the hierarchy. Yeah.
yeah. So in that case, this particular OBJ, we want this
Hmm.
particular OBJ uh, to call payment method for either
Hmm.
PhonePe or Paytm. So we can't pass both, right? So what we can do is we can put UPI payment which can accept both, either PhonePe or Paytm, because it's at the top, and both are implementing this particular abstract
Acha.
class. Yeah,
Okay, 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 okay.
kind
So
of we
this
are
is, ma'am, for the
making.
polymorphism. This
Yes,
is for
yes,
the polymorphism,
yeah,
runtime
yeah,
polymorphism.
right.
Okay, okay,
We are
okay.
making it some kind of generic method. Yeah, we
Acha,
have,
acha, acha.
yeah, in detail you'll learn, but this is kind of
Hmm.
to achieve
Okay.
polymorphism.
Okay, so this is the reason, ma'am, in the line 60 and 61, we are
Hmm.
actually calling this method after creating an object, or creating an object. We are calling this method and we are passing an object actually. We are
Yes,
creating an object of phone pay with the
yeah.
value
Hmm.
and Paytm with the value. So you are passing it, and this obj would uh,
So,
firstly it would
hmm,
mark this, not mark actually, refer to phone pay and then refer to Paytm whenever it gets called for the
right.
second time.
Right. So OBJ can
Okay.
refer to either PhonePe or Paytm.
uh,
Yes,
okay, okay,
that's
okay. So
how it
this
is.
part was slightly confusing for me, but okay, now it's clear.
Yeah, great. Good,
Okay.
good sign. Yeah.
Thank you.
Now, others, Prateek, Rajashri, Adityan, have you done this?
Yeah, yes, ma'am. I was able to get it.
Okay, good. Rajeshri, are you there? And Adityan. If you have doubt, I will solve it. Otherwise, we'll go to next one. Okay, no response. So I'm going to the next question.
Yes, ma'am, I'm trying. You can go through the next one.
Okay, okay, fine. Yeah. If you have any doubt, you can ask. Okay. So the next one is related to interface. So here you have to define an interface appraisable that has the following members. One default method, default void appraisal, that takes a teacher object that increments the salary of an employee by some student pass person by 100 into 5000. So here you have to give a default implementation for this particular method appraisal. Then we have abstract method, public abstract void, check and update salary. Next interface, it is special appraisable, and that extends this particular appraisable and has the following members. One is default method, again default void special appraisal that takes teacher object that increments the salary of an employee by student pass person by 100 into 10,000. So here it's like inheritance between interface. An interface is extending another interface. And remember that when an interface extends another interface, the keyword used is extends. Okay. Next, class teacher that implements the interface special appraisable and has the following members. It has string name, double salary, and private double student pass percentage as private instance variables. Then constructor to initialize these variables, then mutator method to update salary, accessor method to access salary, accessor method to access student pass percentage, because as they are private instance variables, we have to add the accessor public accessor methods. Now you have to override the method to string that returns name, salary, and student pass percentage of teacher as a single concatenated string, each separated by a single space. You can refer the test case to see how the object of teacher is printed out. Then overriding method check and update salary that has the following functionality. So check and update salary should be implemented in this manner. So if student pass percentage, we have to get the student pass percentage, and then if it is greater than or equal to 60 and less than 75, then you have to invoke the method appraisal from appraisable interface. And if student pass percentage is greater than or equal to 75, the other condition is, and if it is less than or equal to 100, anyway, then we have to call the special appraisal method from the special appraisable interface. So here we'll call appraisal and special appraisal according to the student pass percentage. That's about class teacher. And in interface test, we will have our main method. And before that, we have a method called print updated teach list that takes teacher array t list that has the following functionality. It will iterate over array t list, and you have to invoke the method check and update salary on each teacher object. We are taking a teacher array in the sense an array with teacher objects. Then you have to iterate over that particular array and call the check and update salary on each teacher object. Then iterate overtlist and display each teacher object. Two things we have to do. One is you have to call the check and update salary. Second is you have to display each teacher object. Then you have main method. In main method, you have to create and initialize an array t array of three teacher objects. Then invoke method. This method print updated teach list using by passing the teacher array to print the updated details of each teacher after the appraisal is applied. So this is our a template code. Is the question clear?
It's slightly confusing. I mean, the whole thing.
Whole thing. Yeah. So you won't be able to remember everything when you start reading from the top and reach the last actually. So what you can do now, just read once, just go to the template code, and here you see what are the things you have to do. Define interface appraisable, then special appraisable. Here we have the class teacher mostly implemented, instance variables, constructor, everything is given, and get method, getters, setters we have. ToString method is also given, and even check and update salary is also given. Now you have to define the method print updated teach list, and here we have our teacher array. So basically what we are doing is we have a teacher array with three teacher objects, and we want to find, after applying the appraisable, what is the status of each teacher object. So basically that is the thing that we are doing. So using a for loop, creating each teacher object and adding into this array. So for int I equal to 0, I less than t array dot length, which is 3, I plus plus. Here t array of I, t array of 0 will be an object of teacher by taking the values from the user for what, what are the variables that we have? Name, salary, and student pass percentage. Name, salary, and student pass percentage. Then we will create an object of teacher and we will add it to the t array as an element. And after the execution of this for loop, you will get an array, teacher array, with three teacher objects. Basically, each of the element of this particular array will point to one of the teacher objects. Now, here we are calling print updated teach list method that we are yet to define here. And you can see it is called by using the class name interface test. So what does it indicate? As we are calling it using the class name, this is a static method. Print updated teach list is a static method. Let's go through the test case as well. So this is one teacher object. Teacher name is Akshay, salary is 50,000, and this is the student pass percentage. So that is a criteria that we are using to find the new amount for new salary for the teacher. So again another teacher with salary and student pass percentage, and next one. And what we are getting, teacher, the updated teacher should be printed in this manner: teacher name and updated salary. Updated salary is according to the student pass percentage. And here again we are printing the student pass percentage. This is the updated salary for each teacher objects. Now is it little bit more clear?
Yes.
Yeah. Now, can you try it out or should I do?
Okay, so I mean, we can try.
Okay. We have enough time. You can, yeah, try then. If you have any doubt, let me know. I'm here only, okay?
Sure.
Hello?
For loop implementation has been hard.
Sorry, interface or for loop?
Yeah, for loop, ma'am. For loop, that define method that print updated teach list. That thing.
Oh, okay.
That thing is creating issue for me at least.
Just use two different for loops. Yeah, yeah. Use two for loops.
Mhm.
Like do the update in once and then you print it.
Okay, 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 okay.
Yeah.
And now it's working.
Okay. Yeah, you can share your screen.
Ah, okay.
Yeah. I'll also solve it because it's little bit tricky. So,
The tricky part was over here. This is the thing which actually
right,
took
right.
me a huge time because the hierarchy
Mm-mm.
which I had to follow it's very hard because the appraisal thing we have to set the salary. For
Yeah.
setting the salary we have to get the salary first, and the appraisal
Mm.
formula is given in the question which should be this. So for that we need to get this one as well, which is the get student pass percentage on that. So we had to get that as well. So this part, I mean, for the interface implementation part, ma'am, for me at least was a bit tricky.
Mm-mm.
So now over here, the appraisal thing, with what I
Only
did, I just
method.
copy pasted this method name over there from the question for both the things,
Mm-mm.
and then we had to set the salary for the appraisal. So what I did is we have this get salary, and we are passing this teacher thing. So what I did is the class object. So that's why I did t dot set salary since we need to set the salary, which would be the outer side, and within first we need to fetch the salary using t dot get salary, and we need to add that particular formula which they have given in the question, which is this particular part. And for this student pass percentage we have to get it again, so t dot that thing. So this actually worked.
Right.
Again, this check and update salary, this is the abstract method. The first one would be the concrete method, so this has to be the abstract method. And similarly the special appraisal part, again the same thing, but here the formula changes. Here it was 5,000, here it is 10,000. That's the only thing which changes over here apart from this abstract method definition. And also it has to extend
Yeah.
that appraisal interface. Now going to this section, now this is the thing that I asked, like this isn't working for me. So as you said, I just used this first for loop for check and update the salary, and the next used for the printing.
Yeah. Good, good.
So this is the
Output also you
output I
got. Good sign, good. Thank you. Yeah. I'll also just solve it for people who comes later. Yeah. So here, first we have this importing package. Then you have to define the interface appraisable. Interface appraisable, and where is that question? So we have default void appraisal as the method. Just close it. So default method, we can give implementation for a default method in interface. So we are going to give implementation for appraisal method here as what here it is given that you have to increment the salary of an employee, or actually the teacher, by student pass person by 100 into 5000. So that we have to add here. So we are taking the teacher object, and if you see the salary and the student pass percentage all are private variables. So you can't directly add salary equal to salary plus this things. Rather, you have to use the method like get salary accesses and mutator methods. So what we want to do, we have to set the salary, a new salary for the salary variable. So we can use the method set salary that takes the salary and set the value. So we can call set salary method on the object that we have t teacher object, calling set salary method, and how we want to update the salary by this particular formula. So we have to add that particular part. So basically, teacher will, maybe teacher has a salary 50,000. We want to add 50,000 plus whatever that we get as an appraisal amount by applying this formula, right? So we'll get t dot, how to get the salary. We have the method get salary here. So get salary. After getting the salary, then add the extra amount by applying the formula. So the formula is pass percentage by 100, which is percentage actually. Then whatever the salary that the employee already has, teacher already has. So that will be t dot. To get the student pass percentage, again we have student pass percentage method here. Now after getting it, then get it in percentage. To avoid any error, let's use bracket, and we have to get it on 5000, right? Yeah, 5000. So this is what we give here. Get the salary and add whatever that we get using this particular formula. Now that's about appraisal default method. The next thing that we have to add is public abstract void. This particular abstract method in appraisal, appraisable interface, don't give implementation. This is an abstract method. Now that's about interface appraisable. And next thing is we have special appraisable interface, and that should extend appraisable. Is it done? No. So interface appraisable, sorry, appraisable. Why? Think I should type it. So here it has to extend the previous one, appraisable. So this is actually special appraisable that should extend appraisable interface and and it has the following members again: default void special appraisal method, again a default method that will increment the salary of teacher by a different formula. So you have to give a new implementation for the default method. So just change it to 10,000. As it is special, it's 10,000 here, the amount is little bit higher. Then then we don't have anything in special appraisable. Next thing is in our class teacher. In class teacher, we have all those variables and methods and all. ToString method is already overridden. And here we have a check and update salary method. This is going to call the appraisal and special appraisal according to the pass percentage. So anyway, for each teacher object that will have a student pass percentage, according to the student pass percentage, we will call either appraisal or special appraisal method. Now in interface test, we have to do something. So you have to define the method static void print updated teach list. So here in this method, what we have to do, you have to iterate over array t list, and you have to invoke this particular check and update salary on each teacher object. So you have to iterate over the t list. For that we can use a for loop. For how can we iterate? Just there's a variable, and then we want to get the size of this particular list, t list. So it is as it is an array, it can get it using the length attribute, and we will call the check and update salary method on whom? Each teacher object. So each of the element of our t list will be a teacher object. So t list of I, the first teacher at 0th position, that particular object. Then we get an object of teacher, that obj of t check and update salary will call it, and we'll update the salary of teacher object. In this way, we'll call all three teacher objects and get it done. The salary will be updated for each teacher object. And then once we update the salary, what we can do is we have to iterate our t-list and display each teacher object. We have to display, we have to print out each teacher object. For that, we have already overridden the toString method. So we can just print it out by t-list of I. So we will get in this format name, comma, salary, comma, student pass percentage. Interface test. And now, so here we have not added the semicolon. Special appraisal, here this should be special appraisal. Now all good. So the output is 53, 68, 78. Yeah, correct. So we got the output here, the updated teacher objects. Okay, that's it. This is kind of OPP question. I think that's it for today. Any doubt you have?
Just a question I have. It has nothing to do with I mean, particularly any topic or something. I mean, the overall subject.
Okay.
So, ma'am, what kind? I mean, in many papers we have some pattern is like some papers are like theory based. Let's say they ask conceptual questions like what happens like this and that. So in
Mm-mm.
Java specifically, how what kind of questions can we expect in quizzes? Will it be more, let's say, coding based, like we would have snippets of codes and what would be the output, or if
Ah,
there is any
yes,
error or
yes.
something, or there would be conceptual as well?
So basically, we'll have all the questions as Java code. Uh, Mostly, what will be the output, which line will give an error. But at the same time, this is not exactly we are not checking the Java syntax, rather, the concepts that we learned in all these weeks. For example, we learned about multiple inheritance. So we saw how default, if we have multiple default methods, what will happen if there is a conflict, if two default methods are having the same name, those kind of questions. And iterator itself is a concept that we discussed, right, in week 4. So maybe you will get a
Yeah.
question based on iterator, like an imaginary collection we will implement. So I just closed it, actually I had a question. So we will define some, it was linear list, we took an example for linear list, right? Maybe we'll define some other, what we can say, user defined collection, and we'll implement the iterator method, and we'll check on how you can create an object of iter and call it, all those things. So basically it's kind of checking the concepts but using Java only. So mostly the questions will be similar to practice assignments, graded assignment questions. So don't you have access to PYQs? There are some student communities who actually have all those questions. They have a site. Actually, forgot. I don't have that, I guess. So you can check that out. PYQs. We will also discuss PYQs during revision sessions. Clear sign.
Right.
Callback part. Okay. So okay. So you were there when I explained this example. So basically, callback is actually, suppose we have one class and another class, and if we have, if you are creating an object of this particular class here and calling a method of this particular class, start method, and once the start method gets execute completes its execution, it is going to call the method that is present in the caller class. It's not exactly all the time the caller class, it can be different class as well. But what I want to say is, basically, from one class we'll call a method of another class, and from there we'll indicate the other class that this particular method execution has completed. So my class will call the start method after creating an object of timer class, and once the execution is completed here, it will call the timer done method of my class. You got the concept? Okay. So I'll explain this code part again. Here, in this case. In this case, we have this my class. Okay. And here we have a method f method. And in again, here we have another class timer. Just think like you are setting some timer for something, and once that timer, maybe some 10 seconds, after 10 seconds you want to get back to this particular same class. So for in that case, suppose you have my class and f method. Here we are creating an object of timer, and by passing the same object my class, because we want to come back to this particular class once t dot start completes its execution. So we call t dot start, we come here, and whatever the statements after what that we have in start will be executed. And once it completes, we want to invoke the timer done method of my class itself. So in order to do that, usually, uh, so in order to do that, we want the information about who called start method, right? Only then we can call the timer done method of my class. So my class called start method. So we want to know here we want to know who called start method. For that we are having this variable my class owner. We call it as here just given name as owner who called start method, and owner is initialized with the object of my class which called start method. And now owner dot timer done, that will actually invoke the timer done of my class. So basically here we have only two class that are communicating with each other, right? Now did you get it till now? Okay. So only two class. We are involving only two class that are talking to each other. Now we want this timer class to be available for any number of classes, not just one class, multiple classes. But in that case, after execution of start method, we want to call the timer done method of any classes, right? So that will be not just my class, that will be my class, another class, some A class, B class, some different classes. So if we have this honor variable as just my class, then we cannot call other classes, right? That won't be that won't be possible, right? So we want to make this timer class to have a honor that can be anything, any classes. So we want to change the type of honor that can accept any classes that has this timer done method. For that, what we can do is, I'm not going to the object part. Object part is a failure. I'll directly go into the interface part. And what we can do is, we can make a public interface timer owner, and any classes that want to use this timer class object and call the start method must implement this interface timer owner. And here we have the abstract method timer done coming from interface timer owner, and the timer done method must be implemented in this classes. Here again we took my class only. We can have other A class, B class, other classes. There again they can implement the timer owner interface and give implementation for timer done method. Now this is the my class part. Okay, the all the classes that wants to use the timer class must have to implement timer owner interface, this public interface, and give implementation for timer done method. And now in timer class, the changes that we have to make is for the owner we have to make it as timer owner type, because timer owner type can take any classes that implement timer owner interface, right? So we can take either my class or any other classes that implement timer owner. So we made this as a generic one, which means it can be applicable for multiple type of classes, not just my class. So now owner is of type timer owner, and here we initialize with owner as O, whatever that we give while we create the object, whichever the classes that create the timer object, that will be passed as owner. And here directly call owner.timer done. This is possible because timer done method is actually coming from our interface timer owner. So that's how we made timer as a generic timer, which can be used by any number of classes, any type of classes. Type in the sense, I mean the data type, my class, A class, B class, or any other type. Clear? Okay. Yeah. So you can also try executing the code that we gave here and here. So you will see how classes are communicating using callbacks. Any other doubts? Okay. Then shall we stop the session?
Awesome.
Okay. Thank you. Thank you for joining. Thank you for staying till now. Okay. Thank you so much.
Thank you.